today we will go back to the topic of thermocouple, where I promise to show you the temperature measurement based on thermocouple tables. Okay. So before that, let's look back at the principle of thermocouple. Okay. So technically, okay, a thermocouple comprised of two dissimilar metal wire, okay, that always have a sensing junction. Okay, so here, like you can see in the figure in the middle, so we have metal A wire, okay, combined with the metal B wire, okay, creating a sensing junction. Okay, so this sensing junction is basically exposed to the environment or subject that we want to measure the temperature. Okay, and the thermocouple also have another junction, okay, as you can see, a metal B, okay, twisted at the end to a metal A. Okay, so this is usually the reference junction. Okay, reference junction. And at the opening terminal here, so when there is a temperature difference between the sensing junction and the reference junction, so there will be voltage generated at the or at terminal, and usually this voltage we can measure it using a digital voltmeter. Okay, we had discussed the characteristics, the type, okay, the advantages, and also the disadvantages, and most importantly the underlying principle in the past lectures. So today we will look into the concept where to take advantage of the voltage that thermocouple produce. Okay, tables have been developed. Okay, so this table basically uh, represent the table of voltage versus temperature for many type of thermocouples. Okay, example here on the right. Okay, on the right of the figure we have, okay, a table for K thermocouple, okay, where the reference junction, okay, temperature is at 0 degree. So basically, in practical application to the reference junction, okay, we put inside ice bath, for example, ice bath, so that we can keep, okay, the temperature at 0 Celsius. Okay, 0 Celsius. Okay, so this ice bath usually insulated, so that the reference temperature is at constant. So this table, okay, represents the output. Okay, in the middle we have, in the middle of the table is the list of output in millivolt, whereas on the left column here, left column represent the temperature in degrees Celsius, in the increment of 10 degrees Celsius. Okay, on the top row, the increment of temperature in 1 degree Celsius. Okay, so how do we know this table represent the reference junction at degree Celsius? So we look at, okay, 0, okay, first we look at the zero, look at the first column. Okay, look at zero. Okay, and then this zero, so we get the reference of 0 millivolt. Okay, 0 millivolt output at reference 0 degrees Celsius. Okay. So for example, okay, according to the table, okay, for type K thermocouple at 200 degrees Celsius with 0 degrees Celsius, the voltage produced is as follow. So we look at the left, okay, 200, okay, first column here with 200, and then the row here, okay, basically like for example 200 degrees Celsius, okay, first row means that 200 degrees Celsius plus 0 degrees Celsius. So this is the first column, okay, first column, and this is on the row, okay, first row. Okay, so if, so we select at first this row, and then to get the output of 200 degrees Celsius, we go take, okay, this second column which represent the 0, and then it will cross this value, okay, which give us 8.13 millivolt. Okay, 8.13 volt. Conversely, if a voltage of, okay, 29.129 millivolt, okay, in this case, we in most where in this case where we measured the output, okay, from the terminal of the thermocouple, and then we find out that the measurement is 29.129 millivolt. Okay. Okay, and we know that the reference is at 0 degrees Celsius, so we can directly utilize this table. Okay, so at 29129 millivolt, okay, 2919, so we have to go down a bit further. Okay, 29129, okay, exactly here. So the temperature, okay, being measured, okay, we look at the left, on the first column 700, and then we look at the top, it's 0 to 700 plus 0. So the measured is for when the temperature measured at output 29.129 millivolt is 700 degrees Celsius for type K. Okay. However, in most cases, the thermocouple voltage does not fall exactly on the table value. Okay. For example, sometimes the value can be in between. Okay, the voltage measured can be in between. Like for example, this here in between 29.99 and 25.033. So it can lies in between the values shown on the table. Okay, so when this happens, we must interpolate between the table values, okay, that bracket the desired values. Okay, we can find an approximate value of the temperature by using the following interpolation equation. So this is basically interpolation. Okay, so basically we interpolate the values, okay, of the measured temperature, okay, measured temperature, in between the values that is shown on the table. Okay. So in this equation, the measured voltage Vm placed between a higher voltage Vh. Okay, this is Vm. Okay, if, and then this is Vh. Okay, and lower voltage VL is given in the table. Okay, this is VL. This is VL. Whereas the temperatures that correspond to this voltage are TH and TL. Okay, so TH correspond to the higher voltage, TL correspond to the uh, lower voltage on the table. So Vm is the measured voltage, okay, and Tm is our uh, the measured temperature that we want to find. Okay. Okay. For example, look at this example. Okay. Uh, a voltage of 6.22 millivolt is measured with a type J thermocouple at a 0-degree reference. Find the temperature of the measurement junction. Okay. So we use this equation, okay, to find the Tm, or the temperature of the measurement junction. Okay. So first, we need to find the estimate location of the output voltage here, Vm, in the table. Okay. We need to find the estimate value of 6.22. Okay, 6.22 millivolt Vm. So if you look at the uh, table of J thermocouple at 0 degrees Celsius, okay, on the right here, so 6.22 millivolt, 6.22, it should be somewhere here. This is Vm. Okay, somewhere here. Okay, Vm. Okay. So the VL, okay, so, okay, so the VL, okay, VL is 6.196. So this is VL. Okay, so that is basically VL. And VH is here. Okay, so this is VH. Okay, so the objective is to find what is the value of PM. PM is, but we need to know for what is the TL. Okay, TL. So this is VL. So TL, we look at here. We'll refer to this part of the first column. Okay, so 110. TL is basically 110. And then we look at the top here. Okay, so that is basically pardon, there is an equation here. Yes, the reference is 0 degree Celsius in this example. You see, this is 0, 0. You see, the reference is 0. Okay. But the reference is referring to this one. This one is the increment. Okay, increment. So because the temperature difference can go negative. Okay, it can go negative. Remember that in our characteristic of our discussion on the characteristic of thermocouple, the temperature difference can go below negative degree Celsius value. Okay, but here this table is the reference is at 0 degree Celsius. Okay, okay, but usually any table, standard table, okay, refer to 0 degree Celsius reference. Okay, later we'll show you what happen if we have a different uh, reference value, like for example at 10 degrees Celsius. Okay, I will come back to that later. Okay, after this part. Okay, now coming to uh, my point on how to find TL. Okay, TL. So now we have defined where is VL. So find TL, we have to refer to the first the value that VL show or correspond on the first column. So we get 110, and then we look at the uh, top part. Okay, so it is -7. Okay, so basically 110 plus -7. So TL is basically 103 degrees Celsius. Okay, whereas our pH, okay, so similar at the same, so it is at the same point uh, on the first column here. We get the same point. Okay, that we cross the value of pH. Okay, this is 110 plus. Okay, and then we look at the top here. Okay, for PM, this is for pH. Okay, -8. So we get for the pH value, the pH value 102 degree Celsius. Okay, so we have got the TL value and then the pH value. Also, we got the VL values, VH value, and also VM value. So we're going to use this equation. Okay. So the equation Tm equivalent to TL plus pH minus TL over VH minus VL multiplied with VM minus VL. So TL is 103 plus 102 minus 103 over 6.25. Okay. 1 minus 6.196 millivolt degree Celsius multiply with 6.22 minus 6.196 millivolt. Next, we get 103 plus minus 1 multiply with 0.024 divide by 0.0543. Okay, and finally we get 103 minus 0.44, we get 102.56 degrees Celsius. Okay, so you can intuitively check your answer. Okay, so the answer should be in between TL and TH. You see, TL is 103 and TH is 102. So the answer must be in between TL and TH. Here we get that the answer is 102.56 degrees Celsius. Okay, so the measured temperature, okay, at the sensing junction in this case is equivalent to 102.56 degrees Celsius. Okay, right. Now, what happened? What happened in the case where the sensing junction is not equivalent to 0 degrees Celsius? Okay, or so here maybe we don't have the privilege or to keep the reference junction at constant 0 degrees Celsius. So maybe we use the room temperature or any other temperature. Okay. So let's say in some example, okay, where the T reference here is at 10 degrees Celsius. Okay, at 10 degrees Celsius. Okay. So what is when it at 10 degrees Celsius, what is the uh, true EMF? Okay, true EMF here. What is the true EMF? Okay, but okay, when we measure the output, okay, the output, okay, the measurement output, okay, could be in this case Vm is 2 millivolt. Okay, so at 0 degrees Celsius, the V true is equivalent to Vm, whereas when the T ref at 0 degrees Celsius will be equivalent to 0 volt, like this. Okay, 0 volt. Okay, but in this case, where we set the reference temperature at 10 degrees Celsius. Okay, so we need to consider the value, the EMF value when the temperature difference T1 minus T2 equivalent to 10 degrees Celsius plus the measured voltage. So the true output, okay, in this case is Vm plus V 10 degrees Celsius. Okay, Vm is the measured voltage using the voltmeter or digital voltmeter. Okay. So to find 10 degrees Celsius EMF, we go to the table. So we go to the table and then we quickly find the value. Okay, uh, can find that at 10 degrees Celsius. Okay, 10. Okay, plus 0. Okay, so this go down here. So we find that V10, the voltage output. Okay, the 10 degrees Celsius is 0.397 millivolts. Okay, therefore, our measured voltage 2 millivolt plus 0.397. Okay, so the true output is actually 2.397 millivolts. So we have to correct. So we have to do some correction. Okay, because we have to elevate, okay, the temperature reference value to 10 degrees Celsius in this case. Okay, so we basically use the same table to find the correction value, okay, for the thermocouple, right? So uh, for today, so have covered the topics, uh, because I going to give you more time to digest the information and also to spend more time to do the revision and also your assignment. Okay. So next week we will resume, okay, the lesson on RTD, and also we will get into the topic of P and ID diagram. Okay, please uh, immediately, okay, quickly go through my recording. So perhaps you will get the initial idea on the next topic, and also you can, okay, prepare any question that you want to ask. Okay, so that conclude my class for today. Okay, so we will continue our class next week. Okay.